Welcome to our exploration of how airplanes stay in the sky. This seemingly magical ability is actually based on fundamental physics principles. Airplanes, despite weighing hundreds of thousands of pounds, can soar through the air due to four primary forces. These four forces are lift, weight, thrust, and drag. Lift is the upward force created primarily by the wings. It counteracts the downward force of weight, which is caused by gravity. Thrust is the forward force typically generated by engines. It works against drag, which is the backward force created by air resistance. These forces work together in a delicate balance, allowing massive metal machines to defy gravity and transport us around the world. In the following sections, we'll explore each of these forces in greater detail. For an airplane to fly, four forces must be in balance. These forces are lift, weight, thrust, and drag. Lift pushes the airplane upward, counteracting weight or gravity pulling it down. Thrust propels the airplane forward, while drag tries to slow it down. When an airplane is cruising at a constant altitude and speed, these forces are in perfect equilibrium. Lift equals weight, and thrust equals drag. Any change in one force requires a corresponding adjustment in the others to maintain controlled flight. For example, increased speed generates more lift. If an airplane's weight increases, it needs more lift to stay airborne. And if drag increases, more thrust is required to maintain speed. Understanding these four forces and how they interact is fundamental to aviation. Lift is the critical upward force that directly counteracts gravity. It's primarily generated by the airplane's wings and directly counteracts the weight of the aircraft. As air flows over and under a wing, the wing's curved upper surface creates a longer path than the flatter bottom surface. This means air travels faster over the top of the wing, covering a longer distance in the same time compared to air flowing under the wing. According to Bernoulli's principle, as the speed of a fluid increases, its pressure decreases. This creates lower pressure above the wing than below it. This pressure difference is explained by Bernoulli's principle, which states that as the speed of a fluid increases, its pressure decreases to maintain constant total energy. To summarize, lift is generated by the pressure difference between the upper and lower surfaces of the wing. The wing's shape creates faster airflow over the top, resulting in lower pressure above and an upward force called lift. Let's examine the special shape of an airplane wing, called an airfoil. An airfoil is specifically designed to maximize lift. It features a curved upper surface and a relatively flat bottom. This shape creates the perfect conditions for lift generation. As air flows around the wing, it moves faster over the curved top surface, creating lower pressure above the wing. Meanwhile, the relatively flat bottom creates higher pressure below. This pressure difference generates an upward force we call lift. The angle at which the wing meets the oncoming air is called the angle of attack. Increasing this angle generally increases lift, as it creates a greater pressure difference between the upper and lower surfaces. However, if the angle of attack becomes too steep, around 15 to 20 degrees, the smooth airflow can no longer follow the wing's upper surface. This causes the airflow to separate from the wing surface, creating turbulence and a dangerous condition called a stall. During a stall, lift suddenly decreases, which can cause the aircraft to lose altitude rapidly if not corrected. To summarize, the special airfoil shape, with its curved top and flatter bottom, creates lift through pressure differences. The angle of attack is crucial for controlling lift, with greater angles generally increasing lift up to a critical point. Beyond this critical angle, the wing stalls, causing a sudden decrease in lift that can be dangerous if not properly managed. Weight is the force of gravity pulling the aircraft toward Earth. For an airplane to fly, lift must equal or exceed the weight. Aircraft designers carefully calculate weight distribution to ensure proper balance. The center of gravity must fall within specific limits for stable flight. If the center of gravity is too far forward or backward, the airplane becomes difficult or impossible to control. This is why cargo and passengers must be properly distributed throughout the aircraft. When weight is evenly distributed, the aircraft maintains its center of gravity in the safe range. If too much weight is placed in one area, the center of gravity shifts outside the safe range. To summarize the key points about weight and balance, weight is the force of gravity on the aircraft. The aircraft must generate enough lift to overcome weight. The center of gravity must stay within safe limits. Improper CG placement affects controllability, and proper loading ensures a safe CG position. Understanding weight and balance is critical for safe flight operations. Thrust is the forward force that propels an aircraft through the air. Thrust is the force that overcomes drag, allowing the airplane to move forward through the air. Without sufficient thrust, an aircraft cannot overcome drag and achieve the airspeed necessary for takeoff. Jet engines generate thrust by taking in air, compressing it, mixing it with fuel, and expelling hot gases backward at high speeds. Following Newton's third law, as these hot gases are pushed backward, the aircraft is propelled forward with equal force. Propellers, on the other hand, generate thrust by creating a pressure difference as they rotate through the air. The spinning action creates low pressure in front and high pressure behind, essentially pulling the aircraft forward through the air. The scale of thrust varies dramatically across different aircraft types. Modern jet engines can produce tens of thousands of pounds of thrust, allowing massive commercial airliners to reach speeds over 500 miles per hour. Without sufficient thrust, an airplane cannot achieve the airspeed necessary to generate adequate lift for takeoff. As thrust increases, the aircraft accelerates along the runway until it reaches the critical speed needed for liftoff. Thrust is essential for all phases of flight, overcoming drag during takeoff, maintaining cruise speed, and controlling descent during landing. Control surfaces give pilots precise command over an aircraft's movement through the air. Aircraft movement occurs around three axes of rotation: pitch, roll, and yaw. Let's examine how pilots control an aircraft using movable surfaces on the wings and tail. Ailerons are control surfaces located on the trailing edges of the wings. They work in opposite directions. When one goes up, the other goes down. This creates differential lift, causing the aircraft to roll. The elevator is attached to the horizontal stabilizer on the tail. When pulled up, it creates downward force on the tail, causing the nose to pitch up. When pushed down, the nose pitches down. This controls the aircraft's climb or descent. The rudder is attached to the vertical stabilizer. When the rudder deflects to one side, it pushes the tail in the opposite direction, causing the nose to yaw. The rudder is primarily used to coordinate turns and counter adverse yaw effects. In actual flight, pilots use multiple control surfaces simultaneously. For example, a coordinated turn requires proper aileron input for the roll, elevator adjustment to maintain altitude, and rudder input to coordinate the turn. Aircraft also utilize secondary control surfaces like flaps, slats, spoilers, and trim tabs. These help with adjusting lift characteristics, reducing pilot workload, and providing stability in various flight conditions. To summarize, the primary control surfaces are ailerons for roll control, elevator for pitch control, and rudder for yaw control. Their coordinated use allows pilots to maintain stable flight even through turbulence and changing conditions. Let's put together what we've learned about flight. Airplanes stay in the sky through a perfect balance of four fundamental forces. Lift pushes upward against weight, while thrust overcomes drag to maintain forward motion. Wings generate lift through pressure differences around the airfoil shape. Air flows faster over the top of the wing, creating lower pressure above than below. Engines provide thrust by expelling air backward, propelling the aircraft forward. This thrust must overcome drag, the air resistance that opposes forward motion. Control surfaces allow pilots to maintain balance and change direction during flight. Ailerons control roll, elevators control pitch, and the rudder controls yaw. Flight isn't magic, but the elegant application of physical principles. The next time you're on a flight, remember that your journey represents humanity's triumph in understanding and applying the laws of physics and aerodynamics.